All right, so for number 30, we are looking at each set of data, and we are trying to determine which kind of function best fits the data. So we have 4, 16, 64, 256, 1024 for the first one. We have to choose between linear, quadratic, radical, exponential, or logarithmic. So we have 5 different choices. So a linear equation is going to have a constant change in x and y. A quadratic equation is going to have a constant change in x, but the second difference of y's is going to be the same. A radical is going to be switched from a quadratic, so it's going to be just the opposite of a quadratic. So the y will be constant, but the x will have a second, third, fourth, etc. difference. And if we're just looking at a radical, we're probably only going to the second difference. Exponential is going to be multiplying by something in the y value, and a logarithmic is going to be just the opposite, where the x values are going to be multiplied. So those are the different patterns that we're looking for in each of these tables. So let's take a look at the first table, and in this table we notice that we are multiplying by 4. Since we're multiplying by 4, that tells us that this is a constant ratio problem and that this is going to be an exponential graph. Now if we had to determine the equation of it, we had several options here that we could do. We could plug it into our calculator, the data set 1 and 2, and then do an exponential regression equation on it. For the second one, we can see that the y's increase by 5 each time, and the x is increased by 1 each time. So since there's a constant change in x and y, I know that the second one is linear. For the third one, my y's, or f of x, increases by 1 each time. However, the top now is switched. Notice that the pattern is switched. So this is being multiplied by 2 each time. Now since the x value is the one being multiplied by 2, it's going to be the opposite of exponential, and this is going to be a logarithmic function. Okay. For the next one, I can again see that this is plus 1, this is plus 3, this is plus 5, and this is plus 7. Now that means that if you take a look at the second differences, notice how the second difference is the thing that's constant now. Oops, let me undo that. Sorry about that. Okay. Oh. There we go. Okay. So plus 2, plus 2. So since my second difference is constant, I know that this is going to be a quadratic. For the next one, I can see that I'm dividing by 2 each time, which that does indicate that this is an exponential function since I'm dividing. It's the same as when you're multiplying, so this again is an exponential. It's just an exponential with a growth rate of 1/2. Okay. And finally, the last one, this increases by 2, but if you notice that all of these other ones are just adding 1. Okay, so that really is a constant. If we kind of ignore the 0 part and take a look at these 4 values, we can see that these are all increasing by 1. In the top, you can see that from 4 to 9, you add 5, add 7, add 9. Now that tells you that the second difference, so notice the difference between all of these is plus 2. So since all of those are plus 2, I know that since my x values are the one where the second difference is constant, I know that this is going to be a radical function. Okay?